All right, so the next talk is going to be from Matthew Saum from SURFsara. He's going to talk about data archiving in iRODS, and he has his own microphone.
I do have my microphone. Can you guys all hear me? I sound good, right? Good. My name is Matthew Saum. I work in Amsterdam at SURFsara, a subsidiary of SURF. They're a research support agency. They don't own any of their own lab equipment, but they do run the national supercomputer. We do operate a very large tape drive library and HSM system, things like that. Our partner companies under SURF also do things like run the ISP lines. Today I'm here on behalf of SURFsara to talk about how we moved data into a tape library for archiving purposes through iRODS transparently. Do I have slides? Yeah. Most folks are familiar with the data management platform of some fashion. You have your instruments, your user interfaces, and most of us here are plugging it into iRODS of some fashion over your storage locations, whether it is a local storage, an object store, Amazon, or what we're going to focus on is an archive. Now, archiving is often used for non-reproducible data. Anything measuring space pointed out into the galaxy is a one-time gather. You need to keep it for as long as you can. Some things need to be kept for 10 years now. With GDPR in Europe, you have to have your experiment data for so long, and it has to be accessible. Or it's just really, really large, like anything coming out of CERN, and it can only really be stored in an archive. It's not feasible to keep it on spin disk. We have tape for that. As most people are aware, tape comes in most forms of a hierarchical storage management system, or nearline storage, where the user will put their file onto a disk space. It can be NFS mounted, it can be locally connected, whatever. And as far as they're concerned, that file is stored in a storage system. An HSM will then handle automatically behind the scenes migration of that file to tape. And when that file is accessed again, it will restage it to cache so that the user can access their files again without having to manually run any other commands. At SURFsara, we use DMF, Hewlett-Packard's data management framework, on top of a very large Oracle library. We're currently at about 55 petabytes. Previously, at the user group meeting last year, SURFsara presented how EUDAT and iRODS had created a compound resource object connected to a tape library. In that situation, for iRODS, you have a caching file system that is a Unix file system, and a script that moves all of your data to your archive location. Unfortunately, some HSMs involve their own front-end Unix file system already, which means then they migrate it to tape on that behalf. This left a very large communication gap. Once iRODS had filed that data onto its archive resource, it stopped really looking at it until it was accessed again. Once the HSM put it onto the caching front end, it stopped looking at it, thinking it was done. So if anything happened in between, nobody knew. You had to have extensive monitoring to keep an eye on that kind of stuff. What we've done is using the rule engine, we actually have a PEP in place that can allow you to connect an iRODS mounted system directly to the Unix file system front-end cache of whatever tape library we use. My rule was written extremely generically to be plugged in for that. The rule workflow is as simple as this. If a user accesses a data object, any data object, it's going to go through the rule engine. We have a PEP looking for a pre-action on open, so copy, write, and read. And then the PEP says, is it on the archive? If it is not, continue through the rule engine, whatever workflow policies you may have. If it is, then iRODS has to query, is that data online? If it is online, again, we don't care. Continue through all of your rule engines and workflows. But if it is not online, we have to tell our storage system to stage that data from tape to disk cache. When we do that, we have to tell the user they can't have that right now, it's not online. So we interrupt the user action and we tell them to come back later. An example of that, two ways we've enabled it. The first is simply an error message. It says, hey, your data is offline, sorry. The second is a little more automated. It will automatically have iRODS queue the staging from tape to disk, and it will provide feedback. You're at 42% staged. If you're doing 80 terabytes, it's going to take a day. There's no way around that. But it does allow at least users, if they're in command line, to get that, or to pipe this kind of feedback out to any other interface you may have. We've also configured our rule engine to be transparent. We use PEP resource open pre, but if you have multiple instances of that PEP in your engine, then you can wind up with rule conflicts. We've also configured for that as well, so that we can be as transparent as possible in existing environments. The reason this works is iRODS is granular. With their PEP structure of pre, during, and post, you can really finely control all of the actions of a user. We're not really controlling it, the only thing we do is interrupt it, but it gives us that granularity on where do we need to stop user action. And the fun thing we learned is you have full ICAT functionality so long as iRODS can see the file system. In DMF, data streams are moved to tape, but the file system, it's not really iNodes, but it's close enough, are still visible. If you look through that NFS mount, you will see your entire directory structure, all of your data objects, all your files, everything iRODS put there. You can see file names, permissions, everything. Because iRODS can see those, you still have full ICAT functionality. You can change metadata, you can go through and change iRODS permissions, all of it. With the automated migration of an HSM system, iRODS doesn't have to sit there and consistently check, is it back yet, is it back yet, is it back yet? You can, you'll just keep getting more and more feedback on the percentage. And because at SURFsara, we don't run a single ICAT instance. We run one server connected to one university, another server connected to another university, and a third to a third university. We can, using basic Unix security permissions, segregate that data and prevent any form of data contamination where one user can access someone else's data. The reason we went this way is, again, I mentioned the previous system was a compound resource over what is essentially another compound resource of staging and archive. By going to the rule system, we remove an entire resource object from the tree. We have one less script handling data movement, and it's just outright faster because you're not storing your data in 3 locations, you're only storing it in 2 now. Less moving parts means less things that can break. I have an example set up modeled after one of our current use cases. We have the Uni Institute that already has an existing iRODS instance. They're running an ICAT with several resource servers, whether it's NFS or S3, doesn't matter. And at SURFsara, we have the DMF tape library, where we configure an iRODS resource. We join it to their zone, so we are a part of their ICAT-enabled structure. We see their user database in iRODS and all of that. And we mount via NFS4 internally at SURFsara to our tape library, our front-end disk cache of our tape library. That's all 40 gig E lines. I move about, I think it was a terabyte in 15 minutes or so. So internally, we have plenty of speed. Our biggest limitation there is external internet lines. And then this also, because all of the rule set is configured to look for our resource object, the rule file itself only needs to be installed on our resource server. We don't have to go through and update all of your iRODS infrastructure every time something changes. There are some ongoing issues with it, however. First and foremost, I cannot quite figure out how to pipe out custom error messages to remote iRODS servers. I'm still kind of working on that. I can get an error message on the server the rule happens on, and I can get a rule failure error message remotely, but putting nice, fancy custom error messages remotely has been a hurdle for me. There has been some issues just for us if we want to allow users to directly log into our resource server or not. If universities already run all of their own iRODS instance, why should they leave the university to then see the university environment? And tarballing data for tape, because you do not want a sheer amount of small files on tape. You should avoid that if possible. And then some of the long-term things that I have on my table are, I want to get away from the MSI exec command function and write some microservices. The moment I do that, you lose some modularity towards other storage systems, but for us in particular, it's more secure, it's easier to configuration control. I'm working on an idea with a site-to-site tunnel where my server will have an IP address of the university it's at. That way everything in between is an encrypted network tunnel. even if you don't have an SSL-enabled environment, you will have an encrypted connection to our tape library. And I'm currently rewriting for 4.2.3 now because I want to see how well I can incorporate this into their tiered storage system that they're demoing. So, credit where it's due, because this has been an interesting trip. SURFsara has a phenomenal team of their tape library admins and several iRODS experts that I have been lucky enough to work with. Maastricht Data Hub, because they were kind enough to be the first guinea pigs for this entire trip. And the iRODS chat group, between some of the answers I got there and the sheer amount of logged email communication they have that provided such a valid source of why didn't this work. I'm short, I'm simple, and it's not that complicated, so questions, comments, and curiosities?
Can you talk a little bit about the things you have done to try and get error messages cleanly back through the pipe?
I went so far as actually writing a custom error message and building from source inside of the error header protocol and trying to get that registered. However, it appears that when a rule error fails on one iRODS server, that iRODS server will feed back the debug information, such as MSI exit or fail message, whatever you use. But if the user is logged in on any other server, all they will get is the generic rule failed error. I cannot seem to pipe custom error codes across even. Even if I give a custom error code on the resource server itself, the remote server seems to be -1 rule failed error.
And this is in 4.1?
Yeah, 4.1.10, 4.1.11.
Have you tried anything in 4.2 yet?
I am not,
Okay.
because my code has not quite worked.
Yeah, okay. So 4.2 I think is a little smarter in how we've modularized some of that,
Yes.
but I don't know that it answers exactly what you're doing, because we haven't really heard that as a use case.
No.
We can definitely poke at that.
Great.
Any other questions? All right, well, thank you so much.
Thanks.